Good afternoon, everyone. Welcome to this webinar on the Euro 7 regulations, the final rulemaking for light and heavy-duty vehicles, hosted by the Institute of Mechanical Engineers. My name's Alex Wood. I'm part of the Advanced Propulsion Centre UK, and I will be chairing the meeting today. I'm pleased to say that I'm joined by expert speakers Steve Whelan from HORIBA-MIRA and Simon Williams of MAHLE Powertrain. Let's jump onto the next slide, please. It's been 15 months since Steve and Simon last presented an IMechE webinar on Euro 7, and that was following the first drafts of EU 7 proposals from the Commission. At that time, and as was the timeline, Simon correctly predicted that it was likely we wouldn't be reaching conclusions of the proposals until Q1 2024. And here we are. Now there appears that there is a bit of light at the end of the Euro 7 tunnel. So today we're going to look at what Euro 7 looks likely to end up like, identify the areas we still need detail on, and what it means for industry. A bit of housekeeping. We will, at the end of the presentations, for a short Q&A. Please feel free to drop any questions in the chat as we proceed so we can pick those up. Following the presentations, we'd also invite you all to take part in a poll, and the link for that will open up at the end. But because we've got so much content to get through, I'd like to now pass you over to Steve Whelan, who will take us through some of the regulation summary. Over to you, Steve.
Thanks, Alex. Okay, so hello everybody, good afternoon. I'm Steve Whelan. I'm going to start the proceedings by giving you a rundown of the latest Euro 7 regulatory situation, which has just come forth from the trilogue of the European Parliament, the European Council, and the European Commission. So this first slide shows the process, which I guess to a lot of people you don't really see this. So hopefully this slide kind of explains the process that the European Parliament, etc., has been going through. So we started the process back in 2022 with a Commission proposal based on a lot of work done at JRC for proposal of new regulations and new limits. That gets then discussed by the European Council and the European Parliament, which happened through last year, and there was several counter proposals made, and then finally at the end of last year we had the trilogue, which is the getting together of the Commission, the Parliament, and the Council, and recently, in fact, on Monday this week, there's been a preliminary agreement for Euro 7 as a whole, and that will go forward to final Council approval, which will then release the new EU law, which we're expecting to be around June this year. And then finally, after about 20 days, that will be released, an entry into force, as it's called, which we're kind of expecting around July. So the July and the June dates are not firm; they're just based on what we know. So the entry into force date is the key date, because everything else follows on from that date. Okay, next slide, please. So what is Euro 7? So what's new? I've used this slide, or this diagram from the European Commission that published it back in 2022. It gives a good indication of what's new. So unlike any other Euro regulation, Euro 7 has got quite a lot of new stuff in it. For example, brake emission limits, microplastic pollution from tyres, the durability times have been increased. There's more effective emissions testing been introduced, particularly for heavy duty. Significantly change for onboard monitoring being introduced. and also better market surveillance in service compliance. There was a move to make it fuel and technology neutral, but that hasn't quite made it through to the final cut. And there are some new species of pollutant to be measured, particularly in heavy duty, and on-road tests, RDE being extended out to heavy duty. So a lot of new stuff, and in particular battery durability requirements. So Euro 7 now covers all vehicles, including electric and hybrid vehicles. Okay, next slide, please. So what are the headlines? So the first few are from basically what we're used to, the emissions and testing. So for light duty vehicles, the emission limits themselves are basically going to be a kind of carryover from Euro 6E, except PN10, 10 nanometer particulate instead of PN23. There'll be no new species, but evaporative emissions limits are going to be tightened down to 1.5 grams per test. For heavy duty vehicles, there's more change here, more what we're used to really. Again, we've tightened emission limits. NOx is reduced by 50%. NMOG added, possibly the formaldehyde measurement, but that's still in discussion. But there are ammonia and N2O and PN10 coming in for heavy duty. So quite a lot of change for heavy duty. Test conditions, again, for light duty vehicle is a carryover from Euro 6E. That includes WLTP and the RDE protocol. For heavy duty vehicles, UNR 49, the transient and steady cycles carried over, but an introduction of a new RDE testing, which is predominantly dominated by the valid window of having operation anywhere above 6% of max engine power. So again, that's adding a new dimension to heavy duty vehicle certification. And as I mentioned earlier, extended lifetimes are going up to 200,000 kilometers for LDV and up to 875,000 kilometers for heavy duty vehicles with an emissions factor of 1.2. Okay, next slide. Thanks. So these are the new entrants. So these are new, and these are new to Euro emissions. In fact, this has not been put out before. So a big change, onboard monitoring. So the OBM systems must monitor NOx and ammonia on heavy duty, and PM in particular, which I think will be a challenge. And they have to detect exceedances of 2.5 times the emission limits. The data must be communicated via the OBD port and over the air, and the OBM must trigger a driver warning system in case of emissions exceedances. So more detail on that later in the presentation. Brake emission limits, so brake dust. Everybody's probably familiar with the brake dust emission. It's been in the technical press quite a lot recently. It's brake dust is now of the order of tailpipe particulate from diesels. So this is going to be regulated. Currently, brake dust emission limits have only been suggested for light duty vehicles. Heavy duty vehicles will be decided later. The compliance for this limit will be the responsibility of the vehicle OEM. Tyre emission limits based on the tyre abrasion and the microplastics that come off the tyres. Currently, no limits have been decided, but tyre categories are being used, and a time frame has just been announced. Again, more detail of that in the presentation. this will be the responsibility of the tier 1 supplier in this case. And then finally, for the XEV, which includes BEVs, battery electric vehicles, plug-in hybrids, and now even mild hybrids, there's going to be minimum performance requirements for the batteries, based on a 5-year 100,000 kilometre and 8-year 160,000 kilometre. Again, more detail in the presentation coming. The HGV test methodologies are going to be again pushed out and discussed and released in a report by the end of 2027. And the monitors for the what they call state of certified energy and state of certified range, which is effectively the health statement of the electrical system of the vehicle, will have to be monitored by the OBM. So again, another challenge there. Okay, thanks. Next slide. So this shows the timeline. I've tried to make it as simple as possible, but it is quite complicated. So I'll just draw your attention to the top right-hand box. So the red text is showing the fixed dates based on Euro 7 entry into force estimates, and the orange text is what the Commission tasks are in the future, what has to be done and reported. So for LDV, based on our estimate of entry into force early Q3 this year, we're expecting to see the new types coming into force in 2026 at the end of the year in Q4, and then for all types in Q4 2027. And then further out will be 2030 and 2031 for the small volume manufacturers. Heavy duty, again, there's a longer time between entry into force and for the application of the new regulations for new types. Again, that is due to the fact that a lot of the test protocol and a lot of the limit values are still in discussion, and they will be added in that intervening period. So this will push the introduction of heavy duty Euro 7 out to 2028, possibly Q2 for new types, and then 2029 Q2 for all types. And then finally, tyres. The timetable at the moment looks like this, starting in 2028, and final introduction for heavy duty tyres in 2032. Okay, next slide. We now just drop into the details briefly. I'm not intending to go through every number in particular, but just really this illustrates the difference here between Euro 6E and the Euro 7 trilogue situation. And you can see from the table here that indeed Euro 6E is being carried over. The main difference here being the particulate number, the particulate size, PN10, is going to be introduced. There is some work still to be done on R168, but basically R168 is going to be the carryover RDE protocol. Okay, next slide, please. So for heavy duty, again, as I mentioned, heavy duty has a lot more change for Euro 7. There are many new components. So again, this slide shows a comparison between Euro 6 and the current agreed trilogue situation. And the particular NOx and other emissions are reducing. NOx is being reduced by 50%. The big change again is the new RDE requirements for heavy duty, and the RDE driving situation will be similar to that for light duty vehicles. Next slide. So just a quick a quick look at the RDE situation for LDV. As I mentioned, it will be tested in accordance with current UN R168, but that R168 needs updating to include PN10. The new margins, the PEMS margins, are defined, and effectively that gives equivalent conformity factors of 1.1 for NOx and 1.34. So again, that's pretty much carryover from Euro 6E. The new heavy-duty RDE requirements shown here really are basically keeping within a similar altitude of the light duty, but a higher temperature. And the valid window here, as I mentioned, is above 6% max power. So there's still got to be more definition of the heavy duty RDE, and currently the proposed CF conformity factor is 1. So quite a challenge here for the heavy duty vehicle sector. Okay, next slide, please. Euro 7 brake particles, as I said, that's it's going to be introduced. The only definition we've got at the moment is for light duty vehicles, M1 and N1, and the limits are shown here, and it depends on the type of vehicle, whether it's a plug-in hybrid or a battery electric vehicle. This will change the limits. The test methodology is based on GTR 24. That's currently being discussed. And the test methodology for heavy duty vehicles is still open, and that's going to be discussed and agreed in the meantime. So the whole process will be updated in 2030, and then another final update in 2034, and then after 2035 there should be one limit for all powertrain types. Simon's going to give more detail on this later. Okay, next slide, please. Tyre abrasion rate limits. There's not a lot to say here. Basically, no limits have been proposed. The only proposal we have, which has been announced recently, is for the introductory schedule that's shown here. There's no firm test protocol decided yet, whether it's lab or road or both, but there is talk of a real-world based convoy method, which is based on a varying number of vehicles driving similar routes to of around 300 kilometers each. The method mainly is just weighing the tires before and after the test to estimate or calculate the abrasion rate. Okay, next slide. Right, so the diagram here shows, the table here shows the battery durability limits. So this is based on a 5-year and up to 8-year lifetime, and it will vary depending on the type of vehicle. Currently, it's only light duty vehicles, M1 and N1, and as you can see from the numbers there, looking at around 80%, 72% of the charge capability, of the energy storage capability of the battery. This is based on GTR 22, which is well defined, and will apply at the moment just to light duty. Will also be applied to PHEVs and BEVs, and also mild hybrids. So this, and then the final release, and for heavy duty, is still to be agreed, and then this will be released out in the delegated acts. Okay, next slide, please. Okay, then the final new thing, the onboard monitoring. So this is the definition of onboard monitoring, and we've got more information about onboard monitoring coming soon. Basically, it's an onboard monitoring system. So all exhaust emissions of NOx, ammonia, and PM need to be monitored, and any exceedances are over 2.5 times the exhaust emission limits must be detected and logged and stored or broadcast by the system, and this must trigger a driver warning system similar to the OBD MIL light that that currently exists, but this needs to be triggered, and then some kind of action must be taken to encourage the driver to take the vehicle back to get the fault rectified. So very similar as a kind of AdBlue limiting strategy. Okay, final slide, please. So the outlook. So what is the outlook from Euro 7? So from an LDV point of view, I think it's a mixed bag. The emissions and the RDE are mostly carryover from Euro 6E. So with Euro 6E currently in force, the kind of processes and technologies needed for this are going to be pretty similar. So that's not a vastly complex task, but still with the new challenges for OBM, brake emissions, tire emissions, battery durability, these are all big new challenges that will require new technology and new processes. For heavy duty vehicles, I'd say it's a bag of challenges. It's kind of, as I said, business as usual for the emissions, as in it's a new emission level, Euro 7. It's tougher emissions as well as new species and RDE being implemented. So quite a big challenge hitting heavy duty vehicles from Euro 7, plus all the new challenges that are hitting light duty vehicles, albeit introduced at a later date because there needs to be more discussion and agreement on how this will be implemented. Okay, so that's it for me. That's the summary of the current situation, and I'll now hand over to Simon Williams, who will talk about more about the impact of Euro 7. Thank you.
Perfect. Yeah, thanks a lot for that, Steve. Yeah, good afternoon, everyone. So following on from Steve's part of the presentation, what I wanted to do was to go through in a bit more of a deeper dive in the four sections we've got here. So looking at the pollutant emissions, onboard monitoring, the brake and tyre emissions, and battery durability, and what that means for OEMs and what we can do to achieve the challenge of Euro 7. So what we have here is looking at some technology requirements for Euro 7. So from the initial outputs from the Commission for Euro 7, and what we have now from the trialogue, there's been a much smaller change on the emissions requirements. So basically the requirement for light duty vehicle gasoline and diesel applications is change content is smaller, but still there is a requirement for investigating PN10, how we can reduce that. So part of that is through sort of powertrain optimization, looking at injection strategy, lambda control, and sort of general whole system optimization. And then the other option is with advanced filtration GPFs as well, so trying to increase that filtration efficiency of the GPFs. And then in some applications, we may see some electrically heated catalysts as well. But this is not going to be a mainstream technology anymore. This will really be for sort of very niche, low volume applications as we see it. And then for diesel applications as well, similar to gasoline, where we're going to need some possibly powertrain optimization as well to try and get that PN10 emissions reduction, and then looking at your filtration efficiency of your DPFs as well. But really, from a powertrain emissions control system, the change content from Euro 6E to Euro 7 is going to be small. When it comes to heavy duty, as Steve rightly mentioned, there's a considerable change in the emissions threshold, so over 50% reduction in the emissions threshold from where we are with Euro 6. And the other critical factor as well is that the PEMS conformity factor has been removed as well. So for heavy duty applications, it was at 1.5 previously, and for Euro 7, it's going to be at 1. So that's another sort of 50% impact on the emission requirements as well for heavy duty. So both of those changes are going to be a challenge, and there's a number of different technologies that are being investigated within the industry for the diesel heavy duty applications. So different manufacturers we are seeing different strategies from different manufacturers as well. So I've got the full list here. So around different thermal management, optimization systems, so such as Miller cycle and cylinder deactivation, and there's additional hardware opportunities as well. So you look at cooled EGR and preheating as well with after treatment systems, and then there's also then optimization of the actual after treatment system itself. So looking at changing the oxidation catalyst and DNOx systems as well, sort of making them dual SCR systems, for example, and then also ensuring that you get good temperature into your DOCs as well, so potentially improving the positioning towards the engine and sort of the exhaust valves. But there is one thing in this as well, as Steve mentioned. We've only got 50 months to achieve this until Euro 7 is going to be required for heavy duty applications. So there's a lot of testing, a lot of investigation still needs to be done to ensure that these applications are compliant to the new Euro 7 regulations. So moving on to where I believe the biggest challenge is for Euro 7, and this is the onboard monitoring aspects. This is a completely sort of clean sheet proposal from the European Commission. There's nothing like this anywhere else in any other countries. And so it's going to be a requirement for the vehicle to continuously measure the emissions of the vehicle on board. And the requirements are, as we've got NOx and PM for light duty vehicles, and then ammonia as well for heavy duty. One dispensation that has been allowed is that particulate mass can be substituted for a sort of an advanced filter diagnostic, so sort of an advanced onboard diagnostic monitor for your health of your GPF. But still, it's critical aspects of this as well. So you have to be able to include your cold start emissions with your onboard emissions measurement as well. This then brings problems because of the sensors that you'll be using do take time to warm up as well. So it's up to sort of 100, 200, 300 seconds potentially as well. So there's going to have to be methods to calculate the emissions when those sensors aren't ready to be operated. And then these emissions measurements that have been taken on the vehicle will need to be compared back to real measurements performed by PEMS hardware as well. So there's discussions ongoing about the minimum test length that you can compare your vehicle onboard measurements to your measurements with the PEMS hardware as well. So this is around sort of 40 minutes or 20 kilometers has been suggested by the European Commission. So what's the OBM going to be used for? So there's a couple of different aspects of this. So you've got the measurement of the emissions is going to define a sort of a green or red situation on your vehicle. So if you have emissions exceedance with your vehicle, it will then be a red warning to the driver, and then an inducement will be started. And this data as well will also be output to the OBD port and over the air as well. And then from a type approval side and from a market surveillance side as well, this OBM data will be reported out as well for in-service conformity and market surveillance requirements as well. So from a from an in-service conformity point of view, the onboard monitoring and vehicles are going to be emissions tested using in-service conformity. So this is sort of similar to what we have at the moment within Euro 6E, but then as you're performing your in-service conformity test, we're then going to be your onboard monitoring system is then going to be assessed as well. And then the view is to then compare the results from your PEMS kits to the results that the vehicle measures. And at the moment, inside the Euro 7 regulation, it requires a faithful representation of emissions by the onboard monitoring system. So from a development point of view, that's a very difficult sort of statement to meet. It's not really a technical statement of, is it 10% accuracy, 20% accuracy? So there's still a bit of work required to understand exactly what does that mean and how the OEMs can actually achieve that. So yeah, then from a market surveillance point of view, so this is sort of going on from the in-service conformity. So the data on the onboard monitoring will then be provided over the air or through the OBD diagnostic port, and this will then be used by the authorities to understand which vehicle families are looking starting to see emission results above the Euro 7 limit. The view is that these vehicle types or vehicle families will then be assessed against the Euro 7 limit, and potentially up if there's possibly 500 vehicles or 15% of registered vehicles of one vehicle type or one vehicle family that actually is above the OBM or the emissions limit of the Euro 7 emissions limit, for example, then that vehicle family would be a failure, and then there'll be potential recalls required by the manufacturer to be able to fix the emissions of those vehicles. And just to be clear, there is no dispensation against the Euro 7 limits for onboard monitoring. So this really drives a requirement for highly accurate onboard monitoring systems from OEMs as well. So you don't want to have an onboard monitoring system that's over-reading and then causing you to incorrectly be being called in for recall action by the authorities. So it's a very critical point that needs to be investigated, developed, and validated by the OEMs. And the other thing as well, that onboard monitoring needs to be accurate all the way through to the durability requirements of vehicles. So this is up to 200,000 kilometers. So the onboard monitoring and the emissions modeling that will have to be done needs to have that accuracy all the way through the vehicle useful life. So that's quite a significant challenge for OEMs. So how's onboard monitoring going to be achieved? So basically there is a requirement for additional sensors to be placed on the vehicle. So for light duty vehicle, it's going to be NOx sensors. For heavy duty vehicle, it's potentially going to be NOx sensors and ammonia sensors as well. But unfortunately, sort of NOx sensors have not been proved to be brilliantly accurate. So we've got data from the JRC here. We looked into the measurement of standard NOx sensors on a diesel application against the PEMS and lab results. So you can see there's quite a big percentage error in those results, so between 20 and 35% error. A more recent data sets that's been provided by Vitesco. I've got the source of the data and at the bottom of the slide there. It's showing improvements as well, but still sort of plus minus sort of 20% of the accuracy of these sensors against sort of lab-based measurements as well. But the critical point to note as well, that this is when the sensors are hot and warmed up and actually measuring. So then there's a question of how do we actually calculate the emissions during the point of the drive where the sensors are not ready to measure. So really that's then basically emissions modeling will have to be is required to support those cold start emissions, and then supplemented, I think, with OBD systems as well, to be able to then say if there's a component failure which will cause an emissions increase, to then provide that to the onboard monitoring system as well. So really that's a significant challenge to be able to perform that modeling. So then just looking at the sort of the requirements we have. So from a gasoline aspect, there's going to be the requirement for the sensor. You're then going to need to understand, well, how do you actually speciate between the measurement of the NOx sensor, between measuring NOx and NH3, because NH3 is also defined by a NOx sensor as NOx. So looking at simulating that and using the lambda sensor data that's available on the vehicle as well, to then be able to calculate out what's ammonia and what's NOx being measured by the NOx sensor as well. But as we're now in where we are with Euro 7 and type approval requirements within Euro 6E, all applications on the market for Euro 7 are likely to be whole area Lambda 1 operations, so no component protection. So that will then reduce the NH3 generation across the three-way catalyst. From a diesel perspective, so I've got some additional data showing from heavy duty about the impact of sort of NH3 slip on these NOx sensors as well, and how that impacts the accuracy of those measurements too. So then there'll have to be some sort of software manipulation of the NOx result from the NOx sensor, and then understanding where the NH3 is coming from as well, so you can then speciate out the results for your onboard monitoring for NOx and NH3. And then the other thing you will have to do potentially is look at emissions after treatment models as well, to actually understand when there may be NH3 slip events, to then adjust the NOx result as well. So whether it's there's options for hardware and software optimization to rectify the deficiency of the sensors that are available on the market. So like I said at the start, we think that sort of onboard monitoring is actually the most significant challenge of Euro 7 from a technical aspect for the powertrain. So really, OEMs really need to understand how we're actually going to validate these onboard monitoring emissions across all use cases and durability requirements, up to that 200,000 kilometer durability requirements. How we're going to generate, and how the implementation of the emissions models actually going to happen. Sort of this is including the cold start and low temperature cold starts as well. And then the other thing as well is, how do we actually pinpoint the cause of an OBM exceedance? So if we have a high mileage vehicle, less than the durability limit, there may be a number of components that are getting towards their full useful life and then causing the emissions increase. So how does a dealer fix the car to get the emissions down to below the emissions threshold? It might not just be the lambda sensor, you might have to change the catalyst as well. But if you get a customer coming in and just changing one component and then having to change a second component very soon after, that's not going to be a good result for the customer. So these are all complex problems that OEMs need to consider. So one thing that we see as a very big benefit to achieving this is around using sort of virtual calibration techniques, using sort of advanced data collection to be able to then generate emissions models quickly across different powertrain types, different powertrain ages, and different hardware components as well, to build up sort of a broad DOE to be able to understand what the emissions are going to be in those critical cold start areas, to then supplement the data that's coming off the NOx sensor in a light duty application, for example. So yeah, so really to summarize this, it's going to be a real challenge for OEMs to achieve, and we've only got 32 months for light duty vehicles to not only develop the solution, but also calibrate it and validate it as well to meet the Euro 7 phase in 32 months. Moving on now to brake and tyre emissions. So starting off with brake emissions, the development program for brake emissions is going to be a significant challenge for OEMs. I've sort of split it out into two parts. So there's significant investment required into actually the hardware needed to test the brake emissions. So it's brand new systems required, looking at the actual dyno for running the brake system, all the emissions measurement kits to measure the particulates and particulate mass, and all the air handling system as well. So yeah, on average, these are over £1 million per test bench to install into for OEM facilities or tier 1 facilities. So it's a big investment needed. And then there's the investment in the development of the braking systems and the testing, and then the type approval as well, which will all be required by the OEMs to achieve. And then from an engineering point of view, there's sort of considerable impacts of each individual vehicle type, how the braking system interacts with the regen system on different sort of vehicle powertrains as well. So how much regenerative braking you use. So it's not just looking at the brakes, it's also how the brakes are interacting within the powertrain system as well, which then has implications of how the testing's run, and yeah, how you define that as well whilst you're developing the brake emissions. The powertrain development is ongoing, and the impact of, for example, drivability or adaptive cruise control or dynamic sort of energy assistance systems will potentially impact the amount of regen you would get over the brake emissions cycle. So these are all sort of difficult challenges with different teams working on the product to ensure that they're working together to make sure the final answer is defined to be able to support the development and the sort of the validation of the braking emissions. And the other point that Steve alluded to, but the heavy-duty methods for the braking emissions are unlikely to be defined until Q4 2027, leaving under 12 months for heavy-duty applications to be able to prove the process out before the vehicles need to be type approved to the regulation. From a light-duty side, the regulations are almost fixed within the GTR. So we're, from a light-duty side, in a better position to develop systems to the brake emissions requirements. Moving on to tyre emissions, the regulation is still in development. So the limits are planned to be defined in 2025, and then the regulation comes into force in middle of 2028. So these are for light-duty vehicle tyres. As Steve mentioned, there are two methods being proposed. It's clear that the European Commission prefers real-world measurements of this type of emissions, and it's our view that it will be a real-world process that will need to be completed for this emissions requirement. So to clarify what needs to be done, the testing has to be done on the road. There's no test track, so you cannot use a test track or a test facility. The total distance is 8,000 kilometers, which is like repeated 300-kilometer routes. But the interesting point is around the specific requirements of the test. So I've got them in the table here about specific acceleration, temperature, sort of wheel alignment requirements as well, but also weather conditions and maximum and minimum sort of acceleration that can be done as well to try and close down the boundary conditions of this tyre testing. But it does look like it will be a challenge to complete, and it's quite a large sort of investment for tier one suppliers and OEMs to be able to achieve this testing. And yeah, so there is a lot of onus on the tyre OEM to complete this testing as well, but then the vehicle OEM does need to be able to ensure that the tyre that's being used on their application is emissions compliant for their application as well. So yeah, the vehicle OEM does need to be involved in this this testing. So moving on to battery durability, this is sort of a very considerable area, and I've only got a very small amount of information on it. But moving forward, if anyone has any additional questions, I'll be happy to talk about it in more detail. So we're taking on GTR 22, and if we're looking at what needs to happen, so there's, from a type approval perspective, OEMs need to ensure that their battery is durable for the full 8 years, 160,000 kilometers as well. So this is something that most OEMs should be working to at the moment for EV and PHEV applications, but now it's becoming enshrined into regulation to have a minimum performance requirements at that full 8 years and 160,000 kilometers. Where it becomes more challenging as well is when you have to ensure that actually your SOCE and SOCR sort of monitors, so your state of health monitors, are valid for that time as well. So it's ensuring that there are robust methods that can be used to sort of validate the battery technology that's in your particular application, that your state of health or state of health monitoring actually gives the correct result for those fully aged components as well, especially given that battery aging is not only cyclic but also calendar based as well. So that's where it becomes a bit of a challenge to understand what does the calendar aging do to the state of health of the battery in the particular application. The other aspect that's been added on recently to GTR 22 is around virtual mileage calculations. This is all about when vehicles are used for powering external devices. So that's actually another aging metric on the vehicle. So that's actually something that's now been added into GTR 22. And then that's also something that will be checked for in-service conformity as well, whether that virtual distance is calculated correctly and the impact of that on the state of health is actually correctly managed by the OEM. So yeah, so just to summarize, really, I think everyone knows that the Euro 7 sort of for light duty vehicle stringency has reduced from the original EU Commission proposal back in 2022. But I thought I might just say that actually, well, the implementation of the Euro 6D RDE regulation has really had a significant impact in vehicle emissions. So I'm just showing a slight bit of data here from the JRC showing the drop in NOx emissions for diesel and gasoline applications at the point at which sort of RDE EU 6D vehicles came into force, and it's been dropping ever since as well. So really, in my view, Euro 7 is correct to target the additional sources of sort of light duty vehicle and heavy duty vehicle emissions, especially when you start looking at tyre and brake emissions as we're transitioning over to EV applications as well. So these are really the correct things to be looking at and ensuring that the emissions from these sources are being reduced and controlled over the next 5 to 10 years. Even with the reduction in emissions threshold, or the lower reduction in emissions threshold of Euro 7, there's still significant challenges to overcome for OEMs as well to meet Euro 7, especially around onboard monitoring, the heavy duty vehicle emissions against the updated Euro 7 limits for heavy duty, brake and tyre and battery durability as well. So yeah, so with that, that's the end of my section of the presentation. So I really do look forward to answering the questions that have come through. And if there's any additional questions, I've got my details here. They'll be part of the slide deck that'll be provided, and we'll include Steve's on this slide as well. So yeah, thank you very much for listening.
Brilliant. Thank you very much, Simon and Steve, for that. A lot of detail and a lot of ground covered there. Would we be able to have the poll released now for the audience? We're going to be asking you a question on, after all that, not to be led by anything that Simon or Steve have said, but which part of Euro 7 would you all most be concerned about after hearing that, or within your own respective industries? So if we can get that out and going, we'll move to some Q&A. We've had a few questions come through from the audience during that discussion. So I'd like to start with one which is coming regarding timing. So I don't know if we can, maybe Steve, Simon, if you're able to pop your cameras on, maybe even stop sharing. So the question coming, first one's on timing. So it seems like there would be an overlap between Euro 6E and Euro 7. Euro 6E, this FCM would come in 2027 for new types, Q2 I think it is. And that will be quite stringent for the utility factor. Do we think there's any overlap between Euro 6E introduction and Euro 7?
Well, that's a good question. I did think about that when we were looking at the actual introductory times. I'm afraid I've got no official comment from our folk that attend meetings in Brussels, and any particular news from AGVES. I think the only position is there won't be an overlap between Euro 6E and Euro 7. So I guess it will depend on the timing of the vehicle introduction, which will be a tough call for OEMs. Do they introduce it in Europe? Well, probably try and, well, it's probably not going to make a lot of difference, but get it out and get it covered by Euro 6, Euro 6E, and and if it's very close, it's very close. Yeah, that's probably it. I don't know if you got any more.
Yeah. So from my side, our view is that Euro 7 trumps Euro 6E. So at the point at which you've got a new type, if you've rolled over past the type approval date for new types of Euro 7, you will have to certify to Euro 7. I think the question really is around the PHEV for utility factor. So that's around the CO2 type regulation. So that won't be changed. So if you do a Euro 7 type approval, our understanding is that you will need to meet the Euro 6E, like BIS FCM requirements for your utility factor. So the worst case utility factor that's part of Euro 6E, I think I can't remember the designation, like EC off the top of my head, but that's what I would expect would be needed to do.
Okay, thanks very much. Moving on slightly to particulate emissions, so PN10. This is a question on testing. So the questions come in that vehicles subject to PN23 limit, can they have their PN emissions measured by PN10 equipment, capable equipment, both lab and PEMS, as long as the applicable PN limit is reached?
I think I might do HORIBA service here and say, no, you do need to have a specific piece of hardware to do it. So if you have a 23 nanometer car type approved, and you want to do type approval testing, it has to be on a PN23 hardware because of the efficiency metrics and some of the calibration requirements of the particulate measurement kits are not common between PN10 and PN23. So yes, that's the difference, and then won't be a valid result for indication. 100% you could do that, but yeah, for a valid sort of type approval or certification, you will have to use the correct particulate device.
Great. Yeah, thanks, Simon. It's good to get it from an independent source.
So you have to buy 2 bits of HORIBA hardware.
Someone with vested interest. Yeah, thank you.
And just while we're on PN10, there was just a clarity question from someone in the audience around the brake emissions limits and exhaust emissions limits for PN. Are they related or separate?
That's a good question. As far as I know, they're separate, apart from its PN10. It's still 10 nanometer particulate. I know we've, when we're looking at brake dust measurement, we connect our particulate number measurement systems to our brake test systems, and we effectively hoover up the particles and sample them in our SPCS devices that look at particle number. So I think the definition of the PN10 is the same, but the regulations are completely separate. Not sure if that answers the whole question.
Yeah, no, I think that's good. That seems to answer it for me anyway. Simon, you mentioned Lambda 1 in the presentation. So do you think that's something we're going to see on all gasoline engines? Is Euro 7 specifically implying Lambda 1, or is it more of an AES, EU 6E and AES declaration?
Yeah, so it's definitely Euro 6E and AES declaration. So the requirement for Lambda 1 is currently sort of live within Europe. So that's part of the type approval, sort of allowed auxiliary emission strategies or not allowed auxiliary emission strategies. So that's what's driving it. It's not implicitly defined within Euro 7, but our view is with the way Euro 7's changed to become more like Euro 6E from an emissions perspective, we think the AES and the Lambda 1 operation is still going to carry across. So that's our sort of technology viewpoint at MAHLE Powertrain. And that then feeds into what's going on within the EPA as well for the federal requirements for EPA Tier 4 for light duty vehicles. They've stated that they want whole area Lambda 1 as well, with certain aspects that you can run away from Lambda 1 in certain specifically defined conditions, but yeah, Lambda 1 whole area operating map, no component protection, essentially.
Yeah, something that a lot of manufacturers have been used to for a long time, so it's quite a big change for them, right? Mixing slightly over to onboard monitoring and RDE, there's a question here about, well, not that I think that we've got enough challenges with onboard monitoring, but do we think that the different fuel qualities and fuel types and how that comes into the potential modelling, do we see that as a difference even from E5 to E10 or V7 to E10, winter blends, summer blends, all of those kind of things, how they're going to impact onboard monitoring systems?
I think from my side with fuel, for general market fuel, I think the biggest issue that we ever found was around sort of the aromatic content of the fuel and the impact potentially that has on your particulate emissions. So from a onboard monitoring perspective, if you've got like the worst case market fuel, because the way the onboard monitoring is looking at particulate mass, it's on a sort of filter diagnostic, so you can kind of as you're not directly measuring the fuel, you're just looking at the capability of your GPF. There's less of a risk with the change of fuel with sort of a higher aromatic content, for example. Yeah, I think it's a good point, and I think manufacturers will need to validate across a wide range of fuels as well to ensure that their models are accurate, or at least somewhere in the middle of the range of fuels. So example, so you're not calibrating your onboard monitor to your worst case, you're not calibrating to your best case. But again, as well as you'll have a sensor for NOx, for example, you should be able to potentially adapt your model to meet the fuels. So whatever your NOx sensor is reading, if it's caused by the fuel, it will be captured, at least in the hot running once the sensor's operating.
Yeah, I'd just like to add, I think it's going to be a whole load of additional work and activity and complexity. The different types of fuel will have impacts, as we know. There's obviously a lot of work goes on with the fuel companies looking at the impact of different fuels. So I think there's going to be a lot more cooperation needed between the fuel companies and the OEMs with how the different fuel affects the OBM systems. And I think if you take your vehicle outside of Europe, again, that's going to be a real issue. So although we're not part of the EU anymore, but we're fingers crossed still stay aligned to the European regulations here. But we're all right on our little island. We don't really drive anywhere else. But if you're on the fringes of Europe and you drive off into go east or southeast into different regions, that's going to have a bit of an impact on your OBM system. So again, it's not going to be an easy thing to solve. Because again, sorry, just a thought occurred to me. It's if we kind of combine this with the need to decarbonize, because again we can't look at Euro 7 in isolation. There's going to be a proliferation of lots of different fuels, of zero carbon fuels and e-fuels, and again, there's going to have to be some form of accreditation and use of those fuels. We can't not use a renewable fuel just because it might not fall into a specific category in current emission standards. So then, or in regulations in R49, for example. So there's got to be some sort of recognition. Again, that won't make it any easier, for onboard monitoring. But that's not an excuse not to use a renewable fuel, because that, you know, the exam question really is, how do we, you know, stop the planet overheating? We use renewables, yes, and we improve air quality from and maintain air quality through these standards. So they've got to coexist. So I think this is going to be an interesting area. It's a good question, really good question.
Yeah, I think there's quite a few questions. There's a few questions on onboard monitoring in general. So just to that effect, just publishing. Hopefully, the poll results will be visible to people now. But onboard monitoring has come out top of the poll results, and I think we're just about out of time. Actually, we've got a few more questions that have come in. Myself, Simon, Steve, you can find us on LinkedIn. We're also going to be publishing this webinar as well as a slide deck from today. So hopefully we'll be able to pick up any of the questions that we haven't been able to answer in today's discussion. But we hope that you all found it very useful. And yes, stay in touch. Thank you very much for myself and Simon and Steve.
Thank you.
Thanks all for listening.